Everyone, welcome to this video on sets. We want to just go through basic ideas of sets and describe important concepts, right? Let's start with the definition of a set. What do we have when we have a set? What does the word set mean? Okay, the word set just means a collection of objects. That's for maths. When we say we have a set of objects, we are saying we have a grouped collection of objects. Now, when we are grouping these objects, we have ways of then describing our set. We have grouped some objects. So what we're going to do is to then describe it so that whoever else looks at it or comes by can understand what we did, how we grouped the objects, or what is inside our set. Okay, so when we group it, we give the things that are inside the set the name elements. So the things which we are going to group together will then be called the elements of that set. And what we would then do after is to call that set, is to give that set a name. And the name would just be a capital letter. So we'll give a set a name which would just be a letter, and it should be a capital letter. Only that, just a capital letter, and that's what we use as a name of sets. And when we give it that capital letter and we put elements inside, there is a rule that we will then use when we are listing those elements. Okay? And when we say listing, we are talking about one of the ways of representing a set. It's called listing. When we list elements, we do not put their number into consideration or how many elements of each we had. So in other words, if you have a set of, you had 4 oranges, 3 bananas, and 2 apples, then you decide to make a set out of these things, right? What is the first thing you would do? You'd give your set a name. So we can call it set A. Then you put an equal sign. Then you put braces, because that's what we use. Then you list the things that are going to be inside the set. And when you list the things, you do not put the number into consideration. In other words, if you have 4 oranges, you are not going to list oranges 4 times to say orange, 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 and then you say orange again. This is not how you do it. Elements are not listed like this, okay? If you list like this, then all you're doing is, let me say you do it, and you put bananas 3 times. Isn't there 3 bananas? Let's say you were to then put bananas. So I would say banana, banana, and banana, right? And then I would have 2 apples. So I would say then apple, and then write again to say apple, right? And make my set. Now, listing this way, this is the very same way as listing like this. Orange, banana, and apple. Because we are not going to count the oranges 4 times. Okay? We are only going to count it as one element. So in other words, in maths, element is not the thing you have as if I have 4 oranges, I would have 4 oranges as different elements. No, but it is more based on the type of object that you had. So oranges were one type of object. So I'll list it once as an orange. And then bananas were another type. So I should put the banana. Apples were another type. So when you see a set, it tells you the types of things that are inside. It does not tell you their numbers. It tells you that if you come inside, you're going to see a banana, you're going to see an orange, and you're going to see an apple. Those are the things that we have decided to include as the elements of the set. But it won't tell you how many of each there was. That's point number one. Number one is that we do not take into consideration the numbers of our objects when we are listing. The other thing is that when we're listing, we do not care about the order in which the things are listed. So if we say orange, banana, apple, this is the same set as banana, apple, then orange. These two sets are exactly the same. Why? Because they have exactly the same elements inside. We don't care about the arrangement. The arrangement does not create a new set. All right? That's the first thing. So we saw that a set is just a grouping of objects, or it's a collection of objects. And we call those objects that will be inside our set elements of that set. They'll be the elements. And we should always give our set a name, and the name is a capital letter. Then we can be able to then show the representation. Now, we have important sets that we like to always, that we would have you to always know, because you're going to meet them a lot, because you are in maths. And the sets you're going to deal with are not going to be sets of bananas. They're not going to be sets of lemons, oranges, fruits. No, there'll be sets of numbers. You're going to be dealing with sets of numbers, not these other things. So there are some important sets of numbers that you should already be knowing. Sets of numbers. And these are going to be based on what we call the real number system, since you're dealing with numbers. Well, when we say the real number system, you must understand the word real. Real is anything that is, I don't know, in world we could say anything that is practical, that's part of our lives, okay? Real, tangible. So when we are talking about numbers that we call real numbers, these are all numbers in the world. All the numbers that you know, except for a special type of number that we call imaginary or complex number, and that is the square root of a negative number. So when you take the root of a negative number, an even root, like say square root of -3 or even square root of -4, this is going to be an imaginary number. If you try to punch it in the calculator, your calculator will say error. So these are the only type of guys that do not qualify as real. What you must know is that if I take the cube root of -8, I will get -2. So please, cube root does not create for us imaginary numbers. No, it is only the even roots, like root 2, root 4 of negative numbers. That is when we don't have that. That is when we get imaginary numbers. So imaginary numbers are when you try to get square root or fourth root or sixth root of a negative number. You would get an imaginary number. Usually you just see them giving you as the square root. So the square root of a negative number gives you an imaginary number. That is the only type of number we will not consider as real. Anything else, negative, positive, fraction, not a fraction, whatever's root, not a root, all those things will all be real numbers. So, and we'll use the symbol R to represent them, and those are just all the numbers except for the negative, okay? Except for the square root of a negative number. Now, another type of number which you should know, and also not only know it, but also know how it's listed, is going to be the integer. And for integer, we use the letter Z. Z, I can write it in a stylish manner. You could just put it as a Z. I could put it in a stylish manner like this. Same, the difference is the same. So Z like this. This just is for an integer. And what are integers? The special sets that you're going to remember would be all whole numbers, please. I'll give you a tip. They are all going to be whole numbers. So integers are the negative whole numbers, the positive whole numbers, and 0. Okay, 0 is not negative, it's not positive, it's neutral. But we have the negative whole numbers. All the negative whole numbers are integers. All the positive whole numbers, 1 going up, are integers. And 0 is an integer. So how we do it is we like to list them. So if you ask, let's say, let me start by showing you. If you ask to put a set that has the numbers 3, 5, and 7, you'd say B is equal to, then let's say it's called B. We'll just say, we'll open our braces, then say 3, 5, 7. Okay, now if you want to list a set like this is listing, right? When you list, you put your equal sign, open your braces, then write all the things that are inside and separate them by a comma. If you're to list like this, in a way where the elements come to an end, you're able to list all the elements. This is called complete listing. Now, if you were to be told to list a set that is made of the numbers 1 to infinity, 1 going up, all the positive numbers in the world, we could call it letter G. And what it would be like, it would be 1, 2, 3, and you keep going. We can never put all of them down. So what we do is we'll then put 3 dots after the comma like this, going up. And these are called ellipsis points. They are just to say this thing will keep going on like this. It will keep going on in the same pattern that it was going. To say 1, 2, 3, it will keep going on like that forever. And that is how you do it. This is now called partial listing. Okay, so there are times when we have to do partial listing. It's when the numbers are too many. And then if you know all the elements, then you can do it as complete listing. Remember that we'll be telling you the types of things inside, but not how many they were. There could have been 4 3s in this set, but we only put it once. Either way, now let's see how we would then put the good numbers. Integer is Z. So Z is integers, which is the negative whole numbers, the positive whole numbers, and 0. So how we'll do it is we'll put ellipsis points at the back to show that it keeps going in the negative direction. And then we can start from -3 to -2 to -1 to 0, 1, 2, 3, and then put ellipsis points, 3 of them, 3 dots, to show that it will then keep going in the positive direction as well. So here we have shown you what the set of integers is the set of all numbers that are negative, positive, or 0. Okay, they should be whole numbers. No comma there, right? No comma. Now, another type, important one, is natural numbers, which we'll represent by the letter N. You can see them trying to do it in a fancy way like this. Okay, for natural numbers. Now, what would natural numbers be? Natural numbers are also called counting numbers. They are the ones we use to count. How do we count? 1, 2, 3, 4, 5. Isn't that how we count things? Let's say we're counting human beings. 1 going up, and it's only whole numbers. 1 person, 2 people, 3 people, 4 people, 5, 6, 7 people, 8 people. So it is natural numbers are also called counting numbers, and they are easy because they are represented by N, which is for natural, N for natural, right? And that'll be just the numbers 1, 2, 3 going up until forever and ever. So we put ellipsis points to then show. That's another important set, and we are already doing the listing. Okay, here we've done partial listing as well. Now, I want you to know that the set of natural numbers is exactly the same as the set of positive integers. If we only decide to look at positive integers, which we write like this, we'll get the very same set. We write it as Z plus. It means we are only looking at positive integers. We'll get the very same set as the natural numbers. It will be 1, 2, 3 going up. Okay, that is the positive integers. It's the very same set as the natural numbers. Is that okay? Exactly. Now, another set which is very important is going to be the set of rational numbers Q. Okay, we've reached the end. Come on. This one is going to be what? You say, what is the set of rational numbers? Well, rational numbers are, for you to now understand this, we are going to have to change from listing notation into another type of notation called set builder notation. So set builder notation is like this. It is, let's say I want to have a set, and I'll call that set K. And this set, if I list it, it is going to be for integers, okay, or let me say it is going to be for even numbers, only the whole numbers that are even, that are between 0 and 10. So I'm going to say, what are the numbers that are even between 0 and 10? It is 2, 4, 6, 8. Okay, and let's say I'm also including 0 and 10, so it'll be and 10. These are the even numbers. So what I would then say, if I want to write it in set builder notation, this same thing that I've listed, I would say K is equal to, then now do the thing. How do I list? When I'm now writing as in set builder notation, I always do thing number one is to give my elements a letter that is going to stand for them. So we have the name of the set first, which is going to be a capital letter, obviously. Then we are going to choose another letter, which will be a small letter, to represent the elements of that set. So I'll say X will be represented by X. So X is all the values that are in set K. All the values that are in set K are called X's. So it will be represented by X, such that X is even and X is between 0 and 10. So I'll say 0 is less than or equal to X, which is less than or equal to 10. Then I can close my things like that. Okay, I like to use the word and, though, instead of comma. So and, it is between 0 and 10. Now, writing it like this may not be enough because we want only the even whole numbers. So how do we then limit it to only take whole numbers? Well, we know that whole numbers are, we can use integer for that. Okay, we can use integer, we can use natural. So I would say that K is equal to, here's how I do it. I would say integers, okay, X values, which will be, I can put now, the Z to say which will be integers. So K is going to be X values, which are integers. So we are saying, if we read it, we can say K is all this E that you're seeing. I know I haven't told you about it. It just means an element of. So it means that it will be, we say K is represented by X values, which are integers, which are elements of Z. In other words, which are integers. If you are an element of Z, it means you are found inside Z, and Z will be integers. Then now you can say such that X is even, and then you can show that and it is between 0 and 10. So you say 0 is less than or equal to X, which is less than or equal to 10. This is how you would say it. Now, why I did it for you is to see that these guys that we called the special sets that we have been doing, Z, N, Q, these guys are always put before this bar. This bar is to then say such that, okay, when they read it, they say such that, but we would say it is X is an element of integers, and X is the variable that is representing our guys. So we are going to use X. We are going to use X, which will be an integer. So these guys, these Z are put before this bar. So we would say it is an integer. Then now you define it. You put a bar. To put a bar, you say, I'm about to explain to you what X is, because I've chosen X to represent them. Now I'll further explain to you what X is. X is even, and X is between 0 and 10. Okay? So it is a whole number, it is even, and it is between 0 and 10. Okay, for whole numbers, you'd use Z, and we always put it before the bar. All right, that's it. So now, what about for rational numbers? We want to use this set builder notation, this special technique. I would say Q is equal to, I open my braces, then I will choose the letter to represent my set. Now, since rational numbers are fractions, I will use two letters. So I would say it is P over Q. Those are the two letters I'm going to use, P and Q, and I've put them as a fraction. Now I'll define to you such that P is an integer and Q is an integer. Okay? So rational numbers are made from fractions where the top, let's say P is an integer, Q is an integer, and let me say this, the last thing, Q is not equal to 0. This would be it. So what are rational numbers? They are represented by Q, so you should know this third and final letter, Q, or fourth letter. It is to represent fractions where the top and the bottom will be whole numbers. We don't care what the whole number is. The whole number could be negative. The whole number could be positive. The whole number could be a 0 if that is only for the top. The bottom can't be a 0, so that is why we have taken 0 out of it, because we know that integers include 0, but we can't have a 0 in the denominator because it will get, if you go and punch in the calculator to say 7 by 0, you get an error message. So we can't have a 0 in there because it will make our fraction be undefined. So any fraction that is 0 as a denominator is undefined. But as a numerator, we can. 0 divided by 7. This will just give us an answer of 0. So as a numerator, we can. All right, now we're saying that rational numbers are represented by fractions where the top and the bottom will be whole numbers. Okay, so what is negative 3 over 7 a rational number? Yes, because negative 3 is a whole number. 7 is a whole number. We don't care what sign that would be. Okay, what about root 3 over 5? No, it's not, because root 3 is not a whole number. But 5 is a whole number, but root 3 is not, so it can't be a rational. So this is out. What about root of 4 over 5? Yes, this is an integer. Why? Because root of 4 is just 2. So you can simplify it to be a 2 over 5, where 2 is a whole number. 5 is a whole number, so that makes it rational. Okay? So these are special sets that you should know. Z and Q. Remember them. Very, very important. And remember the set builder notation, where you give us the letters and then you will go ahead to explain them. In here, we showed you that it is an element of this. Because we had 2, that's why we wrote them after this bar, okay? But had we just have 1, we would have put it for you before. Okay, we would put this part where we use the special symbols. Anyway, that's it for the first part. We will see you in the next video. Bye for now.